All right, fellas, as it turns out, there's more stuff in section 6.4. Today we're going to talk about the horizontal line test. The essential question is, in what situations do I need to restrict the domain in order to generate an inverse function? Now, I talked about the horizontal line test in the title. So before we get into the horizontal line test, let's talk about what the vertical line test is, because you have used the vertical line test before, and if you remember, it's how we tell if something is a function. So let's take a look at some functions. This line drawn here is that y equals x line. Eventually I'm going to be getting inverses, and so I'm going to be reflecting over it, but for now our original function is in green. So here's our function. It's 2x plus 3, and look, it passes the vertical line test, because every time I pass a vertical line through it, it hits this line just once, meaning that for every x, there is just one y. So this is a function. We're going to be looking at three functions. This is the first one. Next one, okay, x cubed. Let's pass a vertical line through. Yep, looks like I'm only hitting 1 point every time. It gets pretty steep on the ends, but I'm only hitting it once every time, really. So passes the vertical line test. It is a function. Finally, x to the fourth. Again, we're passing the vertical line test. So much for the vertical line test. Now, we're going to get into what is called the horizontal line test. And to understand what the horizontal line test is, you need to remember something about inverses. And the thing that you need to remember about inverses is that inverses are reflected over y equals x. Reflected over y equals x. And since y equals x is a diagonal line, when we reflect over y equals x, the function is kind of turned sideways. So let's take a look at this. Here is the original function, 2x plus 3. Here is its inverse. I calculated the inverse. I don't think we've seen this notation before, or maybe you have. It just means inverse. It's not literally like a -1 exponent. It just means inverse. So these are inverses of each other. And I'll draw a little smiley face to show it. So let's look at the function. So, okay, we sort of see like, here's the original function. The new function is kind of flipped over. It's reflected over y equals x. Now, let's test to see if this function is actually a function. Does this function pass the vertical line test? It does. So where does the horizontal line test come into play? Well, remember how I said that when we reflect over this y equals x line, the function is kind of turned sideways. So what happens in the original function when I turn a vertical line sideways? Well, it becomes a horizontal line. So in other words, when I pass a horizontal line through this function, it's doing a vertical line through the inverse. Horizontal line through here means vertical line through the inverse. Horizontal line through here, vertical line through the inverse. So what does the horizontal line test tell me? The horizontal line test tells me if the inverse is a function. So I use the vertical line test to see if this thing that's right in front of me is a function. I can use the horizontal line test if I only go through one point horizontally. I know that on the vertical line test for the inverse, I'll only go through 1 point vertically. So the horizontal line test tells me if the function has an inverse that is a function. And this is a little bit confusing. If the function has an inverse that is a function. Now, this one is a little bit silly because we're just dealing with straight lines here. Let's look at some extra examples. So, okay, take a look at this one. Y equals x cubed. Now, remember, when I pass a horizontal line through, that means that vertical lines are going through the inverse. And if we notice, every horizontal line that passes through is only hitting 1 point. Even here, it looks like it sort of is hitting 2 points, but it's not, trust me. Even if I pass it right through 0, this is still just touching 1 point. So, since all these horizontal lines are only hitting 1 point, I know the vertical lines on the inverse are going to hit just 1 point, which means yes, this will have an inverse that is a function. Inverse is a function. So where could things go wrong? Let's take a look at our last example. Y equals x to the fourth. Here, yes, the vertical lines pass. This function is a function, but if I pass a horizontal line through, now all of a sudden, actually every single horizontal line I pass is touching 2 points at the same time. This means that the inverse is not a function. Inverse, not a function. Because what happens if I flip this equation over? If I just do a quick reflection, it's going to look something like this, right? Like, look here. This kind of got flipped over and became this. Here, if I flip this over, here is going to be the inverse. Does the inverse pass the vertical line test? Definitely not. And I could know that without even drawing the inverse because the original function does not pass the horizontal line test. So, what I need to do in order to get an inverse is I need to restrict the domain. So here's my strategy. I'm going to restrict the domain. So let's say that x is only greater than or equal to 0. If x is only greater than or equal to 0, I'm only looking at this part of the function. I'm not looking at this part of the function that has x is less than 0. And if this part of the function isn't there, now, does the function pass the horizontal line test? Yeah, definitely, because this part of the function I took away because I'm only looking at the x's that are greater than 0. If I flip just this part of the function over, the positive part, I get this, the positive fourth root of x. Let's look at the negative side. So, looking here, if I restrict x to be less than or equal to 0, this positive part of the function is going away. Now, does the function pass the horizontal line test? Yes. So yeah, when I take away the positive side of the function, now my function passes the horizontal line test. And look at the inverse. Since I'm restricting to only the negative x's, my inverse is now the negative fourth root. And look, it does pass the vertical line test. So let's just quickly recap. My original function, when I flip it over, it is not a function. And here's the reason. If I were to actually solve for this, so flip the x and the y, when I take the fourth root, remember, when I take the fourth root, I need a plus or a minus. So y equals plus or minus fourth root of x. The positive version of the root is reflected here. The negative version of the root is reflected here. But in order to make this a function, I need to restrict the domain. So if I restrict the domain to positive numbers, now I'm taking off this negative part of the function, and I'm only looking at the positive fourth root of x. If I restrict the domain to the negative numbers, yeah, I now can have a function, and it's only the negative fourth root of x. So, just a couple reminders from this lesson. Use the vertical line test to see if something is a function, but if we look at a function, we can use the horizontal line test to see if that function is going to have an inverse that is also a function. And if a function fails the horizontal line test like here, we must restrict the domain like this in order to generate a function in my inverse like this. All right? Thanks for watching.